Hi guys, Missy here. Day 2 of section 4.4 about a theorem called hypotenuse leg. It only goes with right triangles, so it has limited use, but let's go ahead and do a right triangle, the parts of a right triangle before. Right now. All right, so have a right angle. If you go from your right angle, just draw a little arrow across your triangle. It's called the hypotenuse. Right. These two other sides, leg and leg. So in order to use hypotenuse, or HL, leg, you are able to identify, it has to be one of the congruent sides on your triangle. All right, so this is called a theorem. Instead of a postulate. I guess a theorem is a math statement that we prove to be true, or that is proven to be true. We don't prove it to be true so much. We just use it as a rule, like from the geometry gods. All right, so this theorem applies to right triangles. If the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another, then the triangles are congruent. All right, so if I were going to list off my congruent parts right here, I would say that AC is congruent to GE. And that is like a pair of sides, but because it's a special pair of sides called hypotenuses, I'll label it with an H. So you see, go to the right angle, track across your triangle. Those are right triangles. Those are hypotenuses. All right, then we also have AB is congruent to GF. These sides down here. This is a pair of legs. All right, and for some reason, and I sometimes just put it in anyway, but you don't need to say that angle B and angle F are congruent to each other, but you do need to establish that angle B and angle F are right. Because you have to have a right angle in your triangle in order for it to be a right triangle, and you can't use HL unless you have a right triangle. Okay. But like say HRL or something, or HLR, hypotenuse leg right. All right, let's see. For the HL theorem, we don't need to make right angles congruent. Only establish that the triangles have right angles. Okay, and then do you see why this isn't inside angle side order? All right, so if you look, the right angle is not sandwiched in between your pair of congruent sides. So that's why it's not side angle side. If we're side angle side, then you would have to know that A and G were also congruent to each other. All right, down at the bottom here, one of these triangles shows side angle side, one of them shows HL. I personally would pause the video and see if you can look at it for a sec and answer it. All right, there's HL on the side angle side. They're both right triangles. This one shows side angle side because you don't know anything about the hypotenuses. So this is a hypotenuse and this is a hypotenuse. And in order to use HL, you would need to know that the hypotenuses were in fact congruent to each other. All right, going over here, that was marked for you. The hypotenuses are congruent to each other, and that's why the two, and then there's a second pair of legs, and the right triangles. So that makes HL. Okay, here's an example with some more brainstorming. We already talked about midpoint on day 1, but midpoint means that a segment is being divided into two congruent segments. So we're going to look at LN up here, right? Oops, I just broke my little lead in my blue pencil. All right, so if M is the midpoint, so that means you just ignore all the rest of the diagram and focus only on that line segment right there. And if M is the midpoint, you know that LM and NM are congruent to each other, because that's what a midpoint does, is it divides the segment into two congruent segments. LP is perpendicular to LM. So trace out LP, lip, and trace out LM. And what you have is a right angle because the two segments are perpendicular, right? And likewise, you'll do the same thing for QN and MN. All right. And then we know that MP is congruent to MQ. So find MP and MQ and just mark them. So now when you look at your little triangle, you can see the very special order. This is showing hypotenuse leg because this MP side and this MQ side, those are both hypotenuses for these little triangles on the end. The one line you kind of don't need on there is that PQ. So if you got rid of that line, maybe it would be easier to convince yourself that what you have are these two right triangles and they have congruent hypotenuses. And that's helpful. To know. Okay. So our triangles are going to be congruent by HL. So what we need to do is state, let's see. Actually, let's go through the brainstorming. I did the brainstorming without reading it. What does the given M as the midpoint tell you about the diagram? So we said that tells us that LM is congruent to NM. What do the givens of perpendicular segments tell you about the diagram? Okay, so we already marked it, right? When two segments are perpendicular, that means they intersect at a right angle. Perpendicular always leads to right angles. So we know that angle L and angle N are right. All right, and so we have established that we have a HL order. Okay, so MP and MQ. Let's see, that was like the third given, but it's actually written first on the proof. So put an H by that. Put an H by the MP and MQ, right? Because that's a pair of congruent hypotenuses. Okay, if M is the midpoint, what we said is that let us, M is the midpoint. Okay, I guess there's no blank after that, so that's given. And then the perpendicular is given. Let's do step 4. So it would be nice to just have the midpoint, the follow-up to the midpoint step be your very next step, but that's okay. All right, so if you have a midpoint, then the result is you will have two congruent segments. So we said it was L, M, and N, M. All right, if a point is a midpoint, then it divides the segment into two congruent segments. All right, so this is a leg. So we have the hypotenuses, we have the legs, right? It seems like we're ready to say HL. However, the only way we can say HL is if we have right triangles, and the only way to establish that we have right triangles is to state the right angles. So that's why we needed this other given, this given that's on step 3. All right, so perpendicular segments always lead to right angles. So I could say angle angle L and angle N are right, RT right. All right, if two segs are perpendicular, then they form a right angle. All right, I a lot of times just like to put a little R next to that because I'm like, yeah, you do have to have that in your proof. To use HL, you have to establish that you have a right triangle, in which case you have to establish that you have a right angle. Okay, so I think we got it because we have our HL and we have our right angle stated. So we can go ahead and just say a triangle LMP is congruent to, okay, so triangle LMP and MQ, HL All right, so we've got hypotenuses on step 1, legs on step 4, and that's really all you need. If you want to list off where you have the right angles, you can. Like that's, to me, something that it should be like HLR or something like that, but